Hi there. This is going to be week 4. One assignment we're going to do is create a bunch of arrow shooting out and hitting the ground and getting stuck in the ground. So this is a process we call instancer particle instancer. That means every particles is generated is actually replaced by a geometry, and that's what called instancer. So it can be animated geometry. Let's say a bird, a single bird, you make it to flying with wings flapping, and you can actually attach that or replace the particles to that, and then you can go ahead and um, vary the sizes, their velocity and all, and it will be a flocking of birds, which we call. So this is what we are going to do is in this particular exercise, we're going to go create a bunch of arrows shooting outside. And for that, what I am going to do is that I'm going to go stop playing over here. I have already done this one, and a file with the magic numbers, whatever worked in my scene, because it's not going to be exactly the same if somebody else has done and I'm putting those numbers, because it's all matters that what size of the scene is, how big are the arrowheads are, and what are the forces are going into it. So I'm going to go stop it. I am going to give you guys a project folder which will be zipped, um, called this is the zip folder. You will get it, but what is inside it I'm going to go show is that this is a project folder. First thing you will do is that you will use your last name and n particles exercise. Okay, so I'm going to do that. My last name underscore n particles underscore exercises. So this is a project folder which, when you download it, wherever you are going to keep this project folder, you will go to File, Set Project, and navigate wherever you have saved that file, which is this folder, and make Maya look into this particular project folder. So if you double click on it, you will see the scene files. You will see the project folders, and inside this is the scenes folder. I have already made few things for you guys. For example, um, right now what you saw I'm playing is this particular arrow instancer underscore 04. Okay, it will be over there for you if you are curious to take a look at my file. It'll be available to you in this folder. But the asset I have used is the arrow which I model it. It's a very simple one. Let me just open this file, new scene, and um, for a moment what I will do is that I will just drag this arrow into the viewport and continue. So what you're seeing is that, let me just make my background to a little bit lighter color, Alt B. Okay, so here is my arrow. Few things to keep in mind or note is that I have made the pivot of this arrow geometry not at the center. Normally we will be doing a center pivot. No, I have moved it as if it is the heaviest part of the arrow, the arrowhead. So it will look, when it is going to hit the ground, it will look natural as an arrow's path. So that's what I have done. If you are curious how I did it, I actually press the D key and then I move it wherever I wanted it to. Okay, I'm gonna go undo it. All right, so the second thing is, important thing is that the object should always face to the x-axis, okay, towards the positive side of the x-axis. It's very important. Otherwise, the simulation is not going to look right. So once you have the project set, you create your very first scene, you will go and you will open this arrowhead scene from the going into the file menu. Let me just set my project to that. I have it on my desktop and I call it week 4. There's a folder. Inside I have the project folder. I'm going to go double click on it and set it, and then when I go to file and open scene, I'm going to go over here and select this arrow MB, open it. I'm going to not do that. So you will get an empty scene like this. Okay, let me just go ahead and new scene, and I just open that scene. Okay, the arrow. All right, so what I have is there is already a ground plane, which is a ground, and then let me just delete this one. This is my ground geo. I'm gonna go delete the particles too. So my first thing I need to do is, this is how you will get. Okay, so what I'm going to do is, I have already done this one too. So what I've done is that I put this arrowhead into the arrow in a layer over here so that I can actually hide it. Okay, hide and unhide, because this is going to be sitting there. We don't want this one to be rendered because particles are going to go and start representing this arrowhead to really go down, shooting out of the emitter. All right, so once you do that, you will go to file, save scene. I won't do a save scene because we have already this file. We will be overwriting whatever I have provided you. So you go to save scene as, or you go, yes, I will go to save scene as, and for the first time I will call it arrow simulation underscore. I will do a sim, arrow sim. Okay, and I'm going to go save this one. And now it's the time for me to go and create an emitter. All right, so let's change to the effects menu. From the end particles menu set, I'm again going to go to the legacy particles, not end particles, the legacy particle. We are still in the legacy particles. Okay, so over here, create emitter. I'm going to go create an emitter, and this time if I go Control A2, bring up my attribute editor, emitter type is Omni, so I'm going to go change that one to volume. So what's this going to give me is a volume, a cube, and you can see that is coming out from all different angle. So I'm going to go take this one over here to my point. I can actually do it with my top view and place it somewhere around here, and I'm going to go scale that handle roughly, this emitter. All right, so because this is a volume, this one's direction XYZ will be not effective. What is going to drive this is this volume selfish cube. So that's what the cube was. You can actually have different type of volume shapes. And along the axis, so all that is going through is, I'm going to go change this along axis to 15. And if I play now, okay, make sure that you are play every frame and makes max playback speed to 24:1. Okay, so if I play now, you will see the particles are shooting up. Okay, so what I'm going to do right now is um, I will call this one arrow emitter. Delete that. Arrow underscore emitter. And I'm also going to do that same thing. Arrow underscore particles. All right. All right. So now, just for visual purpose, I'm going to go change the arrow particles properties, which will be over here. I have selected from the outliner, and I am going to go to the arrow particle shape on the top. Okay, so I'm going to go click on the arrow particle shape node, and from here I am going to go to the render attribute. Please remember that there are lots of tabs over here, so if you don't see it, please go click on everything, close, and then, so I'm gonna go close everything. Okay, because I know some people are having trouble to find things over here. This is how you will see, okay, if everything is closed, and then you slowly start opening up where what you want to do. Okay, so here, if I go to um, if I go to render attribute and expand that, this is going to give me what I have over here: particles, render type, points. I'm going to go change that to spheres, and I'm going to go add, click on the add attribute for current render type, and the radius. For me, the radius is fine. What I would like to do is that I will add a per object some colors so that we can actually see the particle colors a little bit. So we have already done this one. So what we're going to do is that add dynamic attribute. If I open that one, so here is the color. If I click on the color, it's going to go ask me per object or per particles. At this point, we have nothing to do with the particles. We're just simulating, and we'll replace that with an arrowhead. Oh, sorry, the arrow. So add per particle, add. So now this is color red. I'm going to go make it to 1 so that we can actually see when the particles are coming out, that they're in a nice little red balls coming out, so that it'll be easy for us to visualize, right? Now I'm going to go ahead and select the arrow emitter, and since it is going straight like that, I'm going to go rotate it a little bit in an angle. Will be a 45-degree angle, kind of like that. Depends on like how it's your choice, and it's also like how the simulation is going to come. Okay, so if I play now, it's going to go straight up like that. Okay, so now what I'm going to do is I will add a field or the force which will be from the fields and force. So first thing I need to do is select the particles from the outliner, arrow particles, and then I go to fields and solvers. I'm going to use uniform. Uniform is kind of gravity, but uniform will affect on the mass, which is in our language is weight of the object, um, different. The higher the mass value will behave different with the uniform speed and other. So here is the magnitude 5, attenuation to 1, direction x is 1, and direction z, and so I'm going to go create it. So if I play now, you will see that we don't see that much of effect is happening. So if I go and change the attenuation value to 0, and I'm going to go rewind and play, you will see that it's kind of like going a little bit in that way. So what I will do is I'm going to go change the magnitude, attenuation, and direction. This is, I'm going to go to 0, and the y to -1. So it is going to go come down to right. Okay, so we are getting towards um, some simulations. Then we will start playing with the other attributes of the particles and number of particles and lifespan, etc. So now my um, polygonal ground plane is really um, small piece. I'm gonna go increase that one and move it away from the instancer. I'm also going to go scale this arrow emitter a little bit bigger in z-axis and x-axis. Alright, so if I play right now, you can see that the arrows, let's say assume that arrow, they are kind of like only happening over there. So I want them to, if I want them to really travel longer, so I'm going to go select the emitter, and this along axis 15, I will increase that to say 20. Let's see what's happening. All right, maybe 30. So let's see, rewind and play. Okay, maybe I'm going to go increase a little bit of uniform field, which is here. Uniform field, which is 5 magnitude. Maybe I'm going to go make it to 10. Let's see. Alright, so I'm kind of like happy with this, but you can see that it's pretty much, I want to really vary the mass of this object, the particles, so that each one, by default, each particle is having a mass value of 1 unit or 1 gram or 1 ounce, whatever you say. They are all the same. So by varying, randomizing um, the particles mass, we will have a different effect. So for that, I really need to go into the particles, and then I'm going to go to the particle shape, and here is the per particle, because we want to randomize the particles. Okay, so we can't do it right now. Is 1 means everything is 1. So if we go to the per particle, then we will have controls on each particles in a different manner. So here is a mass. Okay, so we're going to go write a short creation expression. So I'm going to go right click over here, creation expression, and as a creation expression. I'm going to go, here is the arrow underscore particle shape dot mass. I'm going to go copy that over here. So you can select and drag with your middle mouse button to bring it over here, not to Control C, Control V. You can do that, Control C, Control V too. So if I hold Control and my mouse wheel so that you can see it bigger. So what is this? So now I'm gonna go equals rand, if I can type properly. Rand means random, and bracket 0.5 comma 1 and close bracket. So what is happening over here is that it's taking the particle shape mass equals random value between 0.5 to 1. Okay, so each particle will, it's a creation, so by the time of the creation particles are starting, they will adopt a number between these values, right? So I need to close this one within semicolon. That's a standard. There's a little space. No, actually undo it, Control Z. Yes, close and semicolon. This is how we end a line. This is a mathematical expression, uh, sort of coding you can call it. And so now if I go create and I got result arrow particle shape, there is no error message, so I can actually close it, right? So let me play it back and see what we did. So you can see there's a variation of the particles. The heavy ones will travel more because of speed. The uniform is low. The lighter with mass uniform field which we created is varying. That's how some particles are over here, some particles are over here, and they all kind of like breaking down the um, symmetry, taking it look, make it organic. All right, so now I'm gonna go stop. I select my particles and then hold shift and select the plane, and I'm gonna go to the end particles, and I come down all the way to the legacy particles. Here is make collide, and I'm gonna go make that, create that one. So arrow polyplane, if I open this, you will see that this is the normally shape node. We are not going to do anything with that. So, and now if I play, you will see that the moment they are hitting the ground, they are bouncing off from the ground, and the force is equal. You can see that exactly, it's not losing any energy, it's exactly going in like a sine curve kind of things. Okay, so we have to change that in such a way that particles, when they hit, they don't bounce, they will just slide or stick. Okay, so to do that, we are going to use um, let me go to the geometry and Control A to go to the attribute editor. And when we created this collision, we have added a geoconnector to this geometry. Okay, that's the object, and the collision event we created between the particles and the geometry created a geoconnector one, so which has got tessellation factor. Even though this is just a one face, it is actually calculating as 200 faces over here. Complex simulations with collision event, you probably will need to really increase that to higher value so that um, it will work better, the simulation. So resilience, this is the one. If it is, that's what is happening, 1:1. So if I make it to 0, you will see when I play, See, now they started sticking to the surface and then flowing in that direction, right? All right, so now that we know that the particles are hitting and not bouncing and flowing on the surface, so I'm going to go stop here. The friction, okay, the resilience was 1, friction is still 0. So we took it down to 0, the resilience. So now, um, now it has no friction, so it's going good. So if I go and do the friction to be 1 and play, you will see the particles will just drop there, right? Okay, so at this point I really want to save my scene, so I'm going to go file, because I have already done the save scene as to um, arrows underscore seam. I'm going to go to file, increment, and save. All right, okay. Okay, now I'm going to take a look at a little bit more details, that how much of the particles of which direction is coming. I'm going to go move the emitter a little bit top, as well as I'm going to go rotate it a little bit more, shut up this angle, and take a look at it. Yeah, I kind of like that, but it's actually continuously emitting, so I need to play with emitters. Select the emitter, and from the emitter, which is the rate per particle, I'm going to go to the frame 1, and I set a key. I'm going to make it to 200. Right click and set key. So frame 1, I have 200 particles, and then frame, let's say 20, I'm going to go make that one to 0. Right click, set a key. So I have two keys. Frame 1, 200 particles, and in frame 20 is becoming 0. So there will be no particles after frame 20. So that's it, right? Okay. So that's right now I wanted to do that. So it's time right now for me to connect the particles to the instancer which we created. Okay, so I think it's a little too less numbers. If I want to really get some more particles, I actually need to um, change the end frame, which is getting 0 at the frame 20. I'm going to go change that one. This is the number of particles at this point. So I'm going to go hold shift and drag a little that, and so that's keyframe is selected. I'm going to go left click and drag it that somewhere around like 50 or 54, it doesn't matter. So now I will have more particles coming out because it's longer now, the um, when the particles are stopping coming out from the emitter. So and now what I will do is I'm going to go back to the channel box and layer editor. Here my arrowhead, or the arrow, sorry, the arrow geo is sitting over there. Okay, so I have selected my arrow, and now I'm going to go to the end particles and instancer. This is the option box for that. I'm going to go open that option box, and here is the arrow geo already. I'm going to go select that. I will not do anything over here. I'll just leave it as it is, and I create. So now you will see that the spheres sizes are really too big, so I need to really go to the particles arrow, particles, and go to its attribute editor, control A, and I'm looking for particle shape, arrow particle shape. And if I scroll up, um, this radius is 0.5. I'm gonna go make it to 0.02. So pretty much we don't see the particles, but we do see the geometry over here, right? And they're all shooting. I think I should really do is that add a little bit of color to the instancer object. So I'm going to go select the arrow geo, and I go to hypershade, which is the coloring tab over here on the top. I bring that one up. I'm going to go create a new material, so Maya and Lambert. I'm going to go make this one to red color so that we can actually see it. Okay, so once I have this red color here, I double clicked over here in the color channel to bring up this one. Okay, and then I'm going to go select my arrow geo. I can select it from the outliner, and then Lambert 2, right click and hold, assign material to selection. Now you can see, let me just switch up the grid. The arrow has taken that red color, right? And now all our arrows have taken that red color. So let me just play this one again. Okay, so now what's happening, they're coming down but they're lying on a straight on the field, so we need to fix that. So now we have, it's going in the direction but it's not facing into the same direction of the velocity. So what we will do is that we're gonna go, let me just see if I can actually scale this one a little bit bigger. No, that's gonna be way too much over here. I'll just leave it. Okay, so what happened that when we created the instancer, there is an instancer over here, all right? And particle shape, again, everything is happening in a particle shape. And here is the instancer geometry replacement. So if I expand that one, the particles is going to go. So from the instancer geometry replacement tab and the rotation options, I have an aim direction. So if I go click on that, that's none right now, and I change that to velocity. So now if I play, you will see that they're actually rotating, but they're dropping down when they're hitting the collision. That's an event. So at that time when it is hitting the collision, it is actually looking at the original angle of the geometry, so it's actually bringing it to the default place of the arrow what I have in my scene, right? So to fix that, we have to write a little expression again, that is going to be a runtime expression, and that will give us the angle and rest of the simulation. So every time this arrow is colliding, that creates an event. So first collision is event 0, then goes to event 1 and event 2, like that. So if I go to the end particles, and here is particle, let me see, where did it go? Particle collision event editor. So if I open that option box, you can see that here is a creating event, a new event, or event type. So here it is the exactly that the first time the event is happening, I can actually create more particles by typing it at emit, or I can make this same particle split into number of particles and all things like that. So we don't want to do anything over here. I'm going to go um, create event and close this one, and then an arrow particle shape when m direction velocity is set, we're going to go manipulate this velocity in such a way that it will remember the orientation of the end of the arrows so that they stick to the ground, not flat on the ground. Okay, so to do that, I have to add an attribute over here, per particle attribute, and then I will go from there writing a small little expression on top of that, right? So in order to add an attribute over here, I'm going to go click on general. If it is the add dynamic attribute is not on, you have to click on that and general. So that's it's going to open up an add attribute window. The long name, I'm going to go call it arrow underscore sorry arrow underscore direction. All right, and what type of data? This is the data. It's the standard computer language. Vector is 3 quantity, float is also floating point. So because we have direction x, y, z, we're going to go create the vector, and we're going to go add to that to the per particle array, and then I'm going to go add and close this one. So now you will see there is an arrow direction attribute was created for me in this per particle section. So here I'm going to go write again a little expression just the way we did for the mass creation expression. We are going to go right click on it. We're going to go runtime before dynamics. So that's going to go open up here a section where we will be adding a little script, right? All right, actually I need to go and come to the creation expression first, and here we're going to go take this one. So I'm going to go drag this one to and press the enter to over here, arrow underscore particle shape dot arrow underscore direction. So arrow particle shape dot arrow underscore direction equals, it's going to be arrow particle shape dot mass. I'm going to go copy this one, Control C, and I paste it over here. But instead of dot mass, I have to change the name to the velocity. And end with a semicolon. And I click on the edit. So result is arrow particle shape. That's good thing. And if I play now, you won't see anything over here because it's not taking the points, but it's going to be, because it's still looking at this one to the instancer over here. Okay, instancer geometry replacement, everything is happening in this particular arrow particle shape over here. Okay, so still it's in velocity. If I click over here, remember we created a new attribute which is called arrow direction, and that's what it is telling, that use that to the velocity and remember that. So if we play this now, let's see what's happening. Okay. Oh, I didn't change that one. Okay. Okay. Let's see. Okay. Now I need to check what I did wrong, right? All right. Let's play again. The angle is fine, but when they are dropping sort of like going in and um, facing it in a wrong direction ways. Okay. So that means it's not taking control of the particles angle, because this is the angle what it is generating right from the time it's starting. Okay, so it's not taking consideration of what's the angle when it is coming down. So because our expression, which is the any creation expression, which has got that arrow particle shape dot mass random and arrow particle set. Okay, so that's a creation. So that's what it is doing when it is getting created, the very first frame. So it's maintaining that. We need to really write a runtime before dynamics and with some if statement, so that will make those orientation better. So I'm going to go click over here into the runtime before dynamics, and then I'm going to go write a script. So as we discussed, that there is a particles collision event, which is 0, the very first one. So we are saying if arrow underscore, that's my arrow particle shape name, the way I have done arrow particles, and then shape dot event equals 0, arrow underscore particle shape dot, this is the attribute we created called arrow direction, and the per particle array attribute equals velocity, and close the parentheses. This is how we normally do, semicolons. And so I have already done that, so I don't have any kind of like a error message over here. Okay, so now let me just minimize and just play this and see what we got now. Okay, and now they are actually got nicely oriented. All right, but they're kind of like a uniform. Okay, so we are going to go write a little another line of expressions to make it a little bit undulate and take a direction a little bit different angle, otherwise they are all kind of in the same directions. Okay, in order to break this one, we have to really go in and randomize the arrows. um, so we will create again another attribute, um, general, because it's going to be degree. We are going to go to a floating point like 0 0.2, 0.3, 0.3. That's the data type, and I will call it arrow underscore randomize. All right, and I had to properly spell it, randomize, and float, and add it. So, and okay, sorry, close it. So, and now we have a another attribute I have, which is velocity ramp arrow randomize over here. Okay, so we're gonna go write again another expression over here, and that will create a little bit of variations of the rotation angles, right? Now since we created an attribute arrow randomize, I'm going to go right click on it, create an expression, and let me just expand this one, and I am going to go add again the same thing, but I'm providing a number, control C from here, which I have done it already, and let me just go to the next line and I paste it. So we created this attribute, okay, randomize, and arrow underscore particles shape dot arrow underscore randomize equals random value -5 to 5. Okay, so it's going to be anytime it's going to go create an expression. So when it is starting, it's going to go take a number between -5 to 5. And this particular line, while it is over here, will create in a random runtime expression again, and we will add some more lines over there so that it is going to take this number and add it to over there as it is goes runtime and editing it. Okay, so I'm going to go edit, and okay, variable missing. I have to see where is the variable is missing. Okay, I'll be back. Okay, so I had a typo, randomize. I didn't miss the O part of it. So that's, I'll show you that little code is, oops, Control V. You can see that I missed the O over there, so that's why it was giving me error. So it can happen to anyone. It's common that it will come into syntax error or some other thing that is missing attribute. It will tell you. Okay, so I did that and I clicked the edit. So now is arrow particle shape is result. So now I am going to go to the runtime expressions. Let me just kind of like take it down a little bit so that it'll be easier for me. So, and now I'm going to go copy another line of if statement. Control C from here. I have a file, notepad. I have kept those scripts, and I'm going to go paste it over here. So, so now let me see if it is going to give me any error or anything. So if I click on the error, yes, I have somewhere a syntax error. So I have to see where I have made some mistakes, and I will come back. Okay. All right. I think I found where my problem is. A little bit of typo. I missed it. An equal sign. So here is what I'm going to take that entire content. Control, oops, undo, Control C, and Control V. I'm going to go delete this one extra over here. So if I do an edit to it, I still have, oh, this one has to change. Okay, let me see. Alright, so I had missed this one, arrow wasn't there, so I added that one, and there was another one over here equals, I also messed it up, this one equals. So these are the two things. Now I already done that edit after pasting it. So here's the script, and please remember this is very case sensitive. Whenever you are doing something, you have to be very careful. So what I did right now is that I gave a value of 5 greater than or less than, and I created this expression. So let's see what's happening over here. If I go to the scene by closing this expression editor, and I go and play again. So now here comes, and now you can see that they're all in a different angles shooting down, right? So that's basically what we were trying to do at this point. So pretty much we are at the end. Actually, we are at the end, and that's basically what we wanted to do. And I'm gonna go stuff here and just play it once again and start early. You will have some issues while naming conventions and all, make sure that you are naming it properly. Whatever the names you are giving it, that's how you will follow the naming conventions. All right. Okay, I hope you will have no problem doing this exercise.